Good. So you should be able to see my screen, and it should be recording my screen now this time. Sorry, on Wednesday it didn't record the screen, so you just saw my face all the way through. And I'm still wearing my St. Mary's hoodie, an old St. Mary's hoodie. I don't know if you can see that, but Sobe school. But it's cold. I came in from outdoors. Dora took me for her walk, or for my walk. She feels at my age I need more exercise. And, it was cold outside. I don't know where you folks are, and hopefully it's warmer there. We still got 2 minutes that I'll get ready to get my slides. Oh, let me put my slides up here. That I'll show you. Let's see. It's going to work. There we go. That should come in a minute, I hope. Hide that guy. I don't need it. This is slow. Here we are. This is what it looked like first thing in the morning on day 2. So that's today, but back in the fall. And so I was down in Kingsburg then, coping with COVID and lockdown and everything else that we're like in the fall. But it was a gorgeous morning. But at 6:52 this morning, it was still pretty black out there. At 6 o'clock, I could see about 7 boats, about 12 or more boats out in the bay. And there's a mix of two sorts that we'll get this time of year. You've got a tropical cyclone passing by. How cold is cold? And do I pronounce that Bavnisha? Bavnisha? I can't even get you to correct my pronunciation as to how to say it. But Kingsburg Bay, we get 2 types of fish boats out here. This time of year, we've got the lobster season underway. It started back just around Christmas, and there's usually about 5 or 6 boats that are out there, at least when the weather's not too crazy. And but we've also, at nighttime, we get a different set of boats, and these are tuna fishermen. They're somewhat bigger boats, I think, but I can't see them because it's dark. And they use really, really bright lights to attract the fish, or not necessarily attract the tuna. I understand the bright lights will attract smelts and herring and that sort of very, very small fish. And then the larger fish, like sharks or tuna, will go after those schools. And so at nighttime, we see these really, really bright lights out on the water. First, we thought they were smugglers, and I thought, if they're smuggling stuff into the country, why do they light themselves up so brightly? It's not like they're hiding, but no, it's the way tuna boats fish. But this morning, as I said, it was very cold, and so at 7, let's see if we could. There we are. I can't see this one very well. My camera had trouble taking a picture. It was still too dark, and it's not very good job. If you see the little spot here, that's a little crescent moon that was just out there, visible until the sun started to come up. And there are a couple of fishing boats there. Those little white dots aren't just because this is a bad camera, whatever, a bad phone. It's a really old phone, almost old enough to be a flip phone. Anyway, it was a nice morning, and it wasn't until the sun got above the clouds that it got really bright out here. So I asked you to send me pictures, and I'd appreciate pictures from New Brunswick and Ontario and um, uh, Bavnisha. If you've got a cyclone, I presume you're in India or Bangladesh, somewhere in South Asia. Send me some pictures from there too. It'd be much appreciated. And um, for those, I know we had someone that I think said was in Mauritius. Microsoft, or at least my screen opens up each morning with different images, and lately it's been of pictures from Mauritius. It's interesting. Anyway, Osama, um, who's one of the students, has an apartment in Clayton Park, Fairview, Oh, you're in Mauritius. Great. Send me pictures from Mauritius. I'd appreciate that. Uh, with names from Mauritius, it's hard to figure out where you're from because it's, I guess, its origins in part with the slave trade a long time ago. It was a transit point, uh, it seems, and so there is huge, at least of the students I've met, ethnic diversity. Uh, and I think I was told many of them speak Creole, which is probably uh, an African French type of blend. We sometimes hear some from the Caribbean, French islands there that will speak a version of Creole. Anyway, Osama sent me a picture from his apartment. So he's in, if you don't know Halifax, Clayton Park, Fairview, gets up to a steep slope going up that way, up from the Bedford Basin, part of the Halifax Harbor. And I guess this was an evening shot. Yeah, so that would be looking, no, it would be looking east, I'd say, unless, yeah, he's looking to the east. Maybe it's a sunrise. But yeah, there are very few lights on in the buildings. It's probably more like a sunrise. And anyway, you have to attend live class? No, you can watch the recording, or you don't even have to watch the recording. I'd recommend you do. Sometimes they say things that might be helpful for a test or an assignment, especially for assignments. Anyway, hopefully people are here by now so we can get underway. But I welcome photos to be sent along. I've received a few, and I'll try to work those into classes as we go and give you an idea of where everybody is. So slides, move over. Bit of administrative stuff. Uh, I've got about 12 students in my two sections still not in Top Hat, and unless they've signed up since yesterday, they're not here for the class because you've got to be in Top Hat. So we're still struggling to get everybody active and find out where those stragglers are. That some I'm not sure about are communications. That I see they're using a St. Mary's email address. Those are generated automatically when you create an account. But a lot of, and you need it to be able to access Office 365. Some services you need a St. Mary's account, but most of the time you don't, and most of you never look at your St. Mary's emails. And so if you generally prefer receiving emails through Gmail or other types of services, make sure you set your banner email, your preferred email, to the one you use the most often, or you won't get communications from the university unless you don't want to get them from us. And that survey that I send out a reminder to many of you that have not participated. As of last night, we had 103 that had participated. We're up to about 136, I think, just before class. I need to get, or I really want to get about 250 responses. It'll give us a fairly rich then picture of what this class looks like because we want to compare the data from this year to the data from last year, and I'll be using that in some assignments as in class as well. And it's going to be hopefully interesting to you um, that we've discovered, at least I've discovered some interesting things already in it. Do I make mention? Oh, I'll get to. Other updates with the quiz. Uh, I only found one student, I think, that's in Top Hat, didn't answer the quiz. Great. We're underway well. The averages in this section, it was, well, in my two sections, it was 9.7 in one, 9.8 in the other out of 10. That's where I like to see it. I'm happy the closer we get to 10, that it means you've reviewed the chapter, you've at least got a basic idea of what's going on. You may have had to do some checking to get the answers. But even if your first choice was wrong, you made the effort to go back and look and get the right one, which is really, really good. With the discussion as of last night, out of my two sections combined, I've got about 125 students, and we had 99 responses, which is good. Now, every time you participate in a weekly discussion, I tick off one more point towards that. Um, if you participate in 8 discussions over the term out of, hopefully I get 8 posted, then you can use that 8 out of 8 to replace your worst test score, which is good. The contributions I've seen, they're some predictable. I've seen those before. Asked you, how you feel you've been affected by companies or organizations using data analytics, and most of you are seeing it through ads that you see. A lot of it, though, we don't know how they've used it because they don't tell us. They keep their knowledge to themselves, and the really good ones, it's very subtle. Some of you noted that um, some of their ads are annoying or they're not really well targeted. They send you ads for things you just bought. Why do that? That doesn't make sense. That So the really, really successful firms, you don't know they're doing it because they're just so good at it. They're sneaky. Um, and the others are just learning. As I said, with the um, survey, it's coming along. We've got um, last year, bigger class. Our enrollment's down this year due to COVID. But last year I got 344 responses. And we need big data sets to be able to investigate things really, really well. So it's been helpful. And what did I get? Yeah, in the fall, I asked, if you haven't done the survey, it's a whole bunch of demographic things. What's your gender? When do you start? What was your high school average? Bunch of background things. But at the end, the stuff that's interesting to me are open-ended questions. So there are several at the very end. One of them is, what's your greatest fear this term? In the fall, students were really, really stressed about online courses. Many still are, but that they and many raised the issue of grades, primarily, well, some of them about failing, others about keeping scholarships. Um, but there was an awful lot of stress apparent, and a lot of it had to do with COVID and online classes. This term, of the responses that I've read through, and this isn't just from our sections, it's from all of them, uh, the biggest fear for almost everybody is failing. It isn't getting an A or maintaining that scholarship average or whatever. There's a huge fear about failing. None of you should fail. That will I be going over the case exercise in chapter 1? Nicholas asks. Is that the one about Hillary's name? Because I won't, but I will be talking back. Yeah, no, I'd ask you to go through that and think about it. But if you think we should, then I'll bring it into a future class and weave it in. I found it a fascinating story. I'll get to that bit in just a minute then. Um, but a lot of students are fearful about failing. The way the course is built, those quizzes you should be getting 90% or better on average. You may have a few bad days, but otherwise you're going to do extremely well on the quizzes. The tests are a lot harder, or students find them harder because although it's open book, they're limited in terms of time. It covers 2 chapters, not 1. Questions are really, they're very similar, but test scores last term were much, much lower. But still, tests are 40% of your grade. There are 5 of them. The worst one, hopefully, if you participate in discussions, you're going to replace. So you're going to be getting a satisfactory grade. Maybe worst case is a D to a C on your tests, but you've gotten an A++ on the quizzes. And the assignments, uh, if you, they're showing up to the Wednesday lecture before the assignments due, should help fill in the blanks on some stuff. I, I'll probably I should probably post a copy of an assignment with solutions from last term. So you can just see the format and style, because that had a big impact on some of the students. Once they got into the rhythm, they were doing just fine. So I'm expecting you to be getting A's and B's. Uh, I'm not out to fail people. That stresses me when I get failures. So, so last time we talked about what is data analytics. Can I slide that over a little bit? Slide this over a bit. There we go. And today, what I want to do is look at some of the most common data mining applications, classic problems that we look at, and emphasize the process for how do you start a problem and issues to do with completing the problem. So that the we're starting today or next class with data understanding. It's really starting a data mining problem from the data perspective. And if you stick around to the very last class, I'll be talking about implementation. And we work through that. And the process portion is the most important part of the course. The specific tools you're going to forget. And if you need to learn them later, you'll look them up online. You'll find them. I wouldn't worry. Why should you know a number of applications, even ones that we don't go through in any depth? It's trying to picture classic problems. So if you can picture them, that we talked about Target last day, and the marketing people at Target asked two important questions. One was, can you tell me which customers are pregnant? And the second one is, can you tell me when the baby is due? And those are two classic data mining applications. If they were familiar with data mining, it may have prompted them to, I can ask these types of questions. These are things that are useful. So if you're looking at your role in the future, you may not be the data analyst. You probably are, but you'll work with them and you'll want to know what you can get from them. And so it's part of knowing classic applications is helping to prompt questions you can ask. But from the data analyst perspective, it's great because it helps them try to recognize a problem and know how to start it, what type of data they need, what type of tools they might need. Um, is there some best practice? Are there some ethical issues? Are there sort of specific challenges to watch out for? Uh, and if you've been there before, you know what to look out for. So these are a group of fairly classic places where we may have gone before and what to watch out for, some of the dangers and traps. So we tend to, there's a variety of these things. Some involve making predictions. So how many gigabytes of data is this customer going to use? Is this customer likely to switch from uh, service providers, from TELUS to Rogers to some other? And these are questions about predicting future behavior. And then there are others. Most of our predictions have to do with past behavior. So we may want to do some descriptive analysis, find out what is typical behavior. What would be the typical behavior of this particular credit card holder? And they would use that so that when you carry out a transaction, it helps give them insights in predicting fraud. I don't think I've mentioned this before because it's just the start of the class. One of the examples I've got for predicting is predicting fraudulent credit card transactions. And I think back to a number of years ago, I went to Bermuda to recruit high school students to come to St. Mary's. And I hadn't gone to Bermuda before. And it was a relatively new credit card. And it was one I'd never used outside of Canada. The problem came when I went to pay my hotel bill. Uh, my credit card was rejected. TD Bank thought it was being used fraudulently because I'd never used it outside Canada and I'd never been to Bermuda. Um, it created a bit of problem for me in paying my hotel bill, but we got it all sorted. But they had a profile for me of me that they had started to build, and this didn't fit the profile, so they rejected it. Regrettably, 2 years later, when I went to Jamaica for my daughter's wedding, um, they accepted any transaction that was put against my card, including several that were made after I had returned to Halifax and were fraudulent transactions. But they had tried to predict, tried to use a profile of me to predict my things and classify things as fraudulent or not. Uh, but those are descriptive cases where we try to use the description to as a basis for prediction. Some of them just search for specific patterns. If you've been on Amazon, which all of you have, and a lot of other shopping websites, you'll see people who bought XXX also bought YYY, that they're looking at matches and trying to prompt you. Maybe you want to buy YYY. Or LinkedIn will say, do you know ZZZZZ? As someone that may, and it's because of a pattern they've seen in who I've created relationships with, that this might be a good one. That some of them are simplifying applications. I've got so many different customers when I was doing recruitment. There's so many different types of students. Can I cluster them into a small number of market segments to assist me in my messaging? So I will not have to, I can have fairly customized messaging, but I don't have to have a unique message for every single customer because I've clustered certain groups of them. We did that in our recruiting, but we did clusters that we made up. We would have the students from Mauritius or students from Ontario or things, and what are good messages for them. That's not what we'd call a clustering application because we chose the clusters and then maybe we used a profile of people in those groups to help us build messaging. In clustering, I'd like the data to tell me, and maybe it's about other types of things I wouldn't have thought about. So are there certain commonalities among my customers that I can cluster them together? It's very, very useful if you can define those. Other types of things that are still trying to shrink stuff down. I've got so many characteristics of customers, I can't look at all of them. Are there several that are key indicators? We call it feature selection, trying to get down to a small number of things to look at because I can't watch everything. And the other is we've got too much data. Do I need to use all of it, or could I work with a smaller data set? Makes it easier, simpler for me to analyze. And is there a way I should select that smaller data set so that I don't lose too much information? You have to be careful when you're using a subset. So those are some of the common types of things, questions we do. So to give them real names as to what they are, we tend to group them into these ones we call descriptive and I said prescriptive, that should be predictive. Typo there. I'm not, if you did Quant 1 and you did linear programming, that's what's called a prescriptive model. It's telling you what you should do. Predictive models, I'm trying to predict what's going to happen. And just a typo there I should fix. I'll do that after class. So descriptive ones are ones where you're just trying to summarize things. That if you did Quant 1, that was models like break-even models or descriptive models. Now, these applications don't have to be formulas. They may be just a description, a profile. And we're not telling it how to build the profile, just describe what you're seeing. And we call that unsupervised learning, some of the jargon you're going to encounter. And so examples of that, the predictive ones, I should explain, are ones where we're making a prediction. We're trying to predict what's going to happen in the future, that guessing things that we don't know. And so I'm maybe building a formula to make a prediction. I'm predicting how many gigabytes of data you're going to use based upon other characteristics. So you can think of that as a formula. There's an output, an outcome, trying to predict based upon a set of inputs. And to build that type of model, that we've got to supervise it. So we want the inputs to help give us the best predictions of the outputs. And we call that supervised learning. I had trouble initially getting used to this language. Why not just call it descriptive and predictive types of models? This comes out of computing science and their desire to build robots, in a sense, to do artificial type learning that teach a robot to learn, in a sense. It's learning it. As they get more data, it learns more and gets better at making a description or building a profile, or it makes better at making a prediction. And uh, so we call it teaching a machine to learn. And so you may encounter the term machine learning. And there are a lot of people now talking about machine learning that I don't know if it's offered this year, last year, one of the economics faculty taught a course in machine learning in economics. Like, what machines do you need in economics? It's language that I think for some of us creates a barrier. It's harder for us to understand what they're talking about. But teaching a machine to learn, that's creating artificial intelligence. It's not real intelligence because in the sense of a person type intelligence, but this is the language of computer science, and this pops up along here. So examples, classic ones for descriptive or unsupervised learning, clustering, as I mentioned before, grouping them together that are similar to each other in a group, but the groups look different from each other. There's the co-occurrence grouping, that those who bought this also bought that. That's been around for ages. Go into Sobeys to buy strawberries in the summer, and they've got a display of little cakes for making strawberry shortcake. And they've got artificial sweetener or whipped cream on display. If they could put a case of whipped cream for sale, they'd probably do that as well, because people that buy one often buy the other and put them together. So co-occurrence grouping. The other trick that we always learned a long time ago in stuff I used to teach in layout planning, um, you'll find in grocery stores usually the baked items are as far apart from the dairy as possible. They're on opposite ends of the store, because the co-occurrence grouping that we saw in grocery store shopping 50 years ago was you frequently, if you're buying bread, you're also buying milk. They were regular purchases together. And so they put them at opposite ends of the store to make you walk all the way through the store and maybe buy other things. But it was focused on this co-occurrence grouping. Um, Similarity matching is trying to find cases that are similar to one that you're examining. So you're looking at one individual. Do I have others that are similar that we've seen before? People that are, and then based upon that, maybe that gives me some ideas about that type of thing. That so this first is just finding these. This is just describing profiling as we've described, and you may think of profiling of serial killers or that type of thing. Same idea. And then we use the profile to do something else. It's not like clustering. We're taking a group that we've defined and then creating a profile on that group. So we're taking all the serial killers and putting them together and creating a profile of typical serial killers. So we've already got the cluster. Now we're describing the cluster. Uh, and as I've mentioned about things like data reduction, can I shrink it down? Can I pick the most important features? Another key one, and we'll be seeing this one as we work through probably of descriptive things, the one we'll use the most going forward, is called causal analysis. If we see a pattern between A and B, can we describe that relationship? And we describe, if I want to change B, what things should I change to be able to do that? And we'll get to that. Among the pre, I did it again, prescriptive. It must be predictive, not prescriptive. Value estimation, when's the baby due? Trying to estimate a number in the future. Classification, trying to put you into two groups. Are you pregnant or not pregnant? The other one might be link prediction, trying to predict or suggest individuals to add to your social network based upon other members you've got in your network. So again, we're trying to make predictions of the future. Okay. So as I said, when you're getting started, it's easier if you can match things. So when they say which of our customers is pregnant, I'd say that sounds like a classification problem. So how do I start a classification problem? And it's important to get familiar with some of these basic ones. And in the course, we'll look at some, but only a small number. We're going to focus primarily on value estimation and on classification. How am I for time? I'm not doing a very good job because I want to get into this process stuff. So I'm going to leave you with this, unless you can chime in if you'd like on the chat as we go, and this may come up. But you made all kinds of indications of how you thought firms were using data analytics to affect you. Think back to these different classic problems and try to get a sense of what sort of application were they using. In general, they were ones that they're trying to get you to buy something. So they're trying to influence your behavior. But think about, and so that if you were then thinking from the firm's perspective, what type of things should they be? Are you up to or you'd like to do? Give it some thought. Um, oh, value estimation and classification. So we're going to focus and we're going to spend a lot of time on value estimation. We are going to build math models. We're going to use a lot of Excel to try to predict. We're going to be doing things like predicting two main applications, I guess, that in terms of examples, and the same thing exists within the chapters that you'll see in the future. One of them will take an example of given information about a credit card customer, can we predict what their credit card balance will be? How much they're going to owe on their credit card? And that in turn could be used to identify customers that are not using their credit card as much as we thought they would and wonder why. Can we encourage them to borrow more? And or others that are borrowing too much and maybe they're riskier than we thought they were and we may want to change things. It's unusual behavior. Uh, or maybe it's a new credit card holder and we're trying to set a credit limit. And what would be a reasonable one for that customer? How much will they use? And we'll use credit cards, but you could be predicting how much data you're going to need for your phone plan, that type of thing. We'll also use it as an example in predicting house prices. Why are some houses more expensive than others? And can we actually describe that in a very formal mathematical sense as to what a house price should be? But those are value estimation ones, predicting a number. Classification, we're going to do very little in terms of technical examination of building models because Excel isn't that helpful for it. We don't have the tools. But we're going to look at probably 5 or 6 different ways you can do classification. It's a very rich area in terms of different strategies. There is no best way to do it. And there are many, many very different, some very strange at first thought, strategies for classification. That's the determining are you pregnant or not pregnant. But what I want to focus on is the process. It's, for me, the most valuable part of the course. Um, very few others will probably agree with me. But I find very few managers I've worked with are very good at problem solving. They have no idea where to start. And often they start in the middle and they mess things up. So we talk about problem solving in math courses. We don't teach problem solving. We don't teach you where to begin. and how to use it once you're finished, that type of thing. We teach you about tools. So we teach you all the tools to build a house, but we teach you nothing about house construction. Um, we teach you very, very structured problems. The ones we get in practice are messy. Um, and we teach you nothing about problem finding. If you want to do better, you have to look for opportunities, particularly opportunities others haven't seen yet. That's problem finding. It's a process of discovery. You may discover the problem or the opportunity, then you have to figure out what to do with it. But how do you just discover it? Hold on, there's a comment back, I think, from Nicholas again. Value estimation classification. Yes, that classification is one that the prediction is yes or no. It's not a number, it's a category. Whereas value estimation, your prediction is a number. And that's the main difference. It's one is a category, the other is a numeric value. And that is really sort of the split between usually the way we measure things. We measure things either as categories or as numbers. Here we go. So the process I'm going to go through is probably the most common framework. It's nothing magical. It's really, it's nothing new. It's just, it's a classic problem-solving process, but given specific names that fit with data analysis. And it's the one that's used by IBM, SPSS. SPSS is one of the most popular data analysis tools that's been around for a very long time. And they call it CRISP, a cross-industry standard process for data mining. And it's just a sequence of steps. Starts with understanding the business. From that works to, okay, we're going to do data analysis. What's the data that fits with the business problem? And there's a lot of back and forth there. And we'll see that a little bit as we go. It's hard to get deeply into that without having real business problems for us to work at that are big to go and challenge that. Once we figured out sort of what data we'd need and what the data questions are, we get into collecting the data and preparing it. And that requires a huge amount of work. Probably 70 or 80% of your time has to do with just getting the data ready. The rest of it, the modeling, the math stuff, is easy in a sense. The painful portion is getting it ready for analysis. And then we build models. That's where the math stuff really comes in. And we evaluate how well we're doing and do things work properly. And then we try to implement it. And in many instances, the arrow isn't there on my diagram, but we go back to the beginning again. And generally, if I'm thinking this type of cycle we see describing continuous improvement processes, how do you improve an organization? One is identify an opportunity, figuring out how to study it, doing some analysis, doing some evaluation, implementing it, and then going back and seeing what happened. And you keep going round and round and round. So it's continuous improvement. Same thing happens here in data mining. We tend to go solution to one problem feeds into the start of the next. So what are these different steps? As I said, it's circular. You'll notice some of it has backtracking, and there's probably more backtracking than I actually show in the diagram. We're always having to backtrack because as we move through, we discover new things we didn't think of before, and we go back and change things. And that's really, it's not a simple, straightforward, linear process. B, it's often really good to go backwards. That it means that you understand your problem better if you've had to go backwards. Um, the stages, as I said, are not completely separate. You can't often hand them off to different groups because they're interconnected. If you are, you're going to need someone that sort of carries forward and helps the next group in that handoff. That um, they, I tend to lump together data understanding and data preparation. I do both at the same time, and to some extent, I'm doing a little bit of very basic modeling at the same time. So I tend to group stuff together because there's so much back and forth. Then why separate them at all? So in the business one, it's trying to figure out what is the objective? What are you trying to achieve? And very often, I'd go into, in my previous life as a manager, go into meetings and I'd ask, like, when this meeting's over, what do we want to walk out of here and be able to do? What's the objective? Why are we meeting? And very often they didn't know. They knew they had an issue, but they had no idea where to begin. And uh, that they wanted to take action really quickly. And it was very challenging to get them to slow down, back up, and say, but what's the goal? What would success look like? So if we were able, let's not worry about how we're going to solve the problem, but if we could, what would success look like? And can we measure our success? So very much focused on the outcomes. If you can define the outcomes, then I can go backwards and figure out how to achieve them. That, for many, is really hard. In teaching, there's been a push for us to teach learning outcomes. And for many instructors, it's more, they always thought about what are the topics they're going to teach. They're not thinking about when you leave this class, what do we want you to be able to do and why? And what's the outcome at the end? And if you can focus on them and then go backwards, you'll generally do it better. You should also be thinking about the actors. When I talk of this, think of a play, of a performance. There are many actors, from those that are posing the problems, those that are going to be doing analysis, those are going to be using the solutions, the ones that are going to be held accountable when you make a mistake. Is that you? Uh, and it's often the case that the actors have different values and different objectives. They sometimes my staff, frontline staff that dealt directly with students, they had different values and objectives than senior management within the university that didn't deal with the students on a day-to-day basis. My staff were much more student sympathetic, I think, than management was. They understood students somewhat better, a lot better than the managers did. Um, and that sometimes creates conflict in terms of getting things done, getting buy-in. And that's separate from the issue of do they understand data and some of the methodologies, because again, that will affect the way they understand things. So business understanding is about trying to take that very messy problem that people think they have and trying to convert it more into a data problem, one that we can examine. So if I look at Target, they wanted to increase sales. They wanted to change behavior of customers to increase sales. That they understood that if they knew which customers were pregnant and when the baby is due, there's going to be opportunities there for them. That was their situation. And that's the general business problem. It's then making that a very specific question for us to work on. Can you determine which customers are pregnant and when the baby is due? That's something we can investigate. That where they were was somewhat fuzzier up here, and it's very challenging for us. And often when we state the initial problem, it sounds like one statement. But when we change it into specific actionable questions to investigate, this one has two: are you pregnant or not? And when is the baby due is the second one. Sometimes we're going to get a large number of different questions that come out, that each one that we can then investigate and act upon. And it may be a whole set of these things that if we do them all, we'll be successful. But it's forming those. first set of questions. And at least I'm just talking about, and this is general business problem solving. And in my experience, this is rarely done, or it's very poorly done. And so their results are not very good quality. This is a hard task to do. Today, I'm going to keep bringing in the US election because it's a data analytics problem. And I don't know if you can think of what type of data analytics problem is. This is the presidential election, not the broader election for Senate and Congress and the like. What are they trying to do with the US presidential election? And do you know which type of application it is? Any thoughts? No. Classification, generally, I'm not predicting a number, but classification, it is, but it's an awkward one because there's actually several processes. They go through a long process in the US with the way they've structured it, with primaries and that sort of thing, to come up with a short list of potential presidential candidates. And the primaries are that sort of thing. There's a group that have been put forward in the primaries of possible candidates, and then you're going to end up selecting out of that the one that's the best. So you're going to classify it as, yes, this person should be president, or no, this one should not be, and we can only classify one person as having it. And then the final stage, the November election, was getting it down to those last two. Is it going to be Trump or is it going to be Biden? But the business problem, somewhat fuzzier, that there we're looking at trying to selecting a person is separate from selecting that leader we're going to have for a very big country and a powerful country, and trying to think of it isn't just a person, but the potential and the opportunity to lead. And so it carries with it a selection that has got lots of support behind it. It's going to be able to mobilize the country. It gets to be a lot more complicated than that. So you may end up adding additional types of questions in there. The users in this, or the ones that we're studying, do they have shared values and objectives? Given the demonstrations and debates and all that sort of thing, no, there's a huge amount of diversity out there in that. And the debates over votes, the votes are data. And there's challenges to, is the data valid or not valid? And there's challenges to the process of generating that data. And a lot of the debate has been about the process because most people don't understand it. Similarity matching, Nicholas raises, you want to find voters that are more similar to your base. You may be looking for that in speaking out to them. But for this, and that may be part of your strategy in campaigning. For if you're campaigning, if you're doing the Biden campaign or Trump campaign, is finding people similar, how to speak to them, or finding profiles of them. That you may be finding, if your classification problem is, how do I find people that are going to, or make them say yes, or make them say no? So if I have a causal model, how can I influence them so it'll encourage them to say yes or no? In chapter 1, I make mention, if you're looking at profiles of people doing data analysis, make mention of Cambridge Analytica. That's a firm, had some Canadian connections. They were involved in the 2016 election in building models to influence voters. And there's questions about how they got access to data about voters. But they tried to build models so that they would influence people to vote yes or no, or vote Trump or not Trump. It generated a lot of controversy in terms of, is this an ethical way to do that type of thing? once you've defined it, we've then got to think about data. And there I got to figure, like, what data do I have? What data do I need? I've tried to formulate the question and it involves data. So in this one, it's votes, I guess. How do I get it? How do I obtain that data? And sometimes it's data that I can't get. Um, what does the data look like? We'll focus more on that. We'll look at some of these ones in Wednesday's class. And what's the quality of that data? And that is part of the debate in the US election process, was challenges to the quality of it. Some of the data we'd like we can't get. When I was doing recruitment, I wanted to recruit. I could get data about all the students that had applied to St. Mary's, and I could compare those that actually enrolled to those that didn't enroll. And so of those that applied, I could identify indicators of it, who I'm going to be able to sell St. Mary's to and who I may not be able to sell St. Mary's to. But if I really want to grow enrollment, I've got to attract people to apply that have never applied before. Why did a student choose to go to Dal, not come to St. Mary's, and they applied to Dalhousie, but they didn't apply to St. Mary's? Because they didn't apply to St. Mary's, I know nothing about those students. So how am I going to get it? How am I going to get that data? And that's data, unfortunately, I can't get. So sometimes if it's trying to identify new customers, we're going to want data that we actually can't get. Not always, but there's sometimes ways around that. Not in Canada for student recruitment. In the US, there is. So if I was looking at Target, they had a lot of different data about their customers. And they can also buy more data. In the US, they have less privacy restrictions than we have in Canada to be able to get data that they can buy and trade and sell. But for my specific question on pregnancy, the key thing I want is those women. I don't want male customers. I want female customers that have signed up for the baby registry. That's the key group I've got, because those are ones that were pregnant at some stage. And it's got the due date, shopping records, and that type of thing. So I'm drilling down to that's the data I want. There's lots of other data out there. Don't be distracted by it, because it doesn't have to do with our question. Make sure you maintain your focus. You don't creep out to look at other things. And so I can start working through that and build a profile, say, of pregnant customers. With the US election, it's challenging because actually there are two stages. There's the votes, that's the first round, and then the selection is made by the Electoral College. So data is actually transformed. They take it from vote data into Electoral College votes. And the process for changing that varies by state as to how they do that. They're both, we can think of as data, but collecting it, the processes for collecting it were different in each state. In terms of, could you do mail-in ballots? Could you drop off your mail-in ballot? Or did you have to, what do you have to do in person? What about signatures? What are procedures they've got? And most of these court challenges in the US have been associated with that process for data collection. And that in some states, because of COVID, they made some changes in the processes. And is that valid or not valid? And they're raising those issues because they're questions of quality. Not all data is the same. One of my big problems with any sort of study is missing observations. I'd like to be able to build a profile of this class, but if you don't answer the survey, I don't have data about you. Those that don't answer the survey, are they different? Oh, yes, they are, because they didn't answer the survey. They're different in that regard. But in what other ways are they different? And is that going to change things? Are they less engaged students? Am I getting responses from the really keen, engaged students, but not getting responses for those that are not engaged? And that we often see differences in response rates to surveys based upon gender. Women usually respond better than men. By age group they're in, old people do it as a sense of duty, whereas younger people, don't have time for it. A variety of those things. And so you may overrepresent some groups and underrepresent others. We get data entry errors that happen. And can we spot those? Um, that we have what we'd call misunderstanding errors. They didn't understand what they were being asked about and gave us the wrong thing. There are all kinds of questions about data validity. And we'll see that because we're going to look at the survey data and we're going to get some garbage in that survey data. Um, Even administrative data. If I pull data out of Banner about you, there are going to be errors in it. That there's always some problems in it. So that's really important about, and how many errors have I got? And is it a big problem or a small problem? And it varies. But this is a very important issue, and that is why there's been one of the reasons there's been so much debate about the US election. We don't get that debate in Canada, it seems. So I've got to select and extract the data, actually go and have people vote, and then I've got to go through and clean it. Yeah, uh, we clean it, and even with elections, you clean it. We transform it. We recode stuff. We filter stuff, sort stuff. So data preparation, often we're exploring the data so that we know what is an unusual value. So we're into some aspects of doing exploration. We're going to be doing that as well so that we understand our data before we get into the big, heavy modeling stuff. So we don't get into garbage in, garbage out. We've got to make sure we've gotten rid of the garbage here. With Target, they had so much transaction data. They had to take all of those transactions and shrink it down. So maybe they're going to group all purchases of body lotion or all purchases of vitamins just as vitamins, or as, without concern of how big a bottle or small a bottle it was, what brand it was, those types of things. So we're creating new variables by shrinking stuff together. Maybe we're going to look at average purchase per month or something, but the raw data is hard to work with. I would have difficulty working with your transcript data. So maybe if I was looking at performance or some idea of, are you a strong student or a weak student, I'll just look at your grade point average, which has taken all the raw data about your individual grades and averaging it. I lose a lot of some insights in that, but it's easier to work with. So we do some of those things in preparation. In the US election, we've got to think about who's allowed to vote. In some states, certain groups aren't allowed to vote. Um, they did some cleaning. They threw out ballots. They said, no, this is a spoiled ballot. It's invalid because of they did one thing or something to it. And there are debates about these. Um, More of it should have been cleaned out from Trump perspective. That I guess they figured all the bad ballots were ones for Biden, so they didn't have any bad ones for Trump. Don't know. And there's a lot of mistrust about the ballots in the US. I haven't heard that in Canada, but in the US, it's a frequent debate. They've got a very, very complex data collection process. It's not centralized control, it's very decentralized how it's done, and many more opportunities for confusion as to how it's done. So their data is messier than ours. In modeling, we then start thinking about these different types of classic data mining applications, and we may build a formula, a decision rule. We'll be looking at those as we go through, and they take on different forms. It isn't always a formula. And that, unfortunately, is the way too many people think about these. There's a lot of very simplistic ways we draw decisions from data that formula is sort of in our head, or it's in a picture, that uh, sometimes we end up using several tools on the same problem. to help us shrink our data set and organize it, but maybe we go through multiple steps. And it isn't just one application, one tool that we use. We may use many, many tools. Just like in building a house, we use many tools for the different tasks or parts of the house. That and a lot of problems we can attack several different ways, and in many instances there is no best method for doing it. And so different people will use different methods and they reach different answers to it. I might show you an example of that in just a minute, depending upon how far overtime I get. But let me come back to that one. Choosing the best one is challenging. You got to think about it. With Target, they found that they could make very, very good classification and value estimation predictions based upon a fairly modest amount of variables. They took a lot of data, shrank it down by at least 25 products, but it may be a very complex, two complex models for determining who was pregnant. They did that using, I don't know the math behind it, but it was one where it involved scoring customers, and then if your score was above a threshold, you're pregnant, below it, you're not. And that's a particular strategy used in classification we'll get to in another month or so. With the US, that's been really messy. In the US, their modeling is moving through the electoral college process of converting data into decisions. And they've got a process that's not, that is a formula in a sense set by their constitution in the electoral college system. And this most recent round of affirming things was challenges to those sorts of process. So all of these different approaches we use, we're going to make mistakes. We're never perfect. So we will need to get a sense of different types of performance measures. And we don't just use one performance measure because there are different types of errors and different types of consequences. That it'll be with the value estimation, predicting a due date, that we may want to have, errors would be, well, we predicted the baby would be born on the 25th of the month and the baby was actually born on the 28th. So we were off by 3 days. So our error is the number of days. But we may, predicting, having the error being the baby was born before the due date or after the due date, we may view as having different consequences. Being 3 days early, 3 days late, is that the same? Being a month early, those happen, and those have certain consequences. A month late, something's wrong, the baby's dead. Those are very, very different things of before and after, that type of thing. That's in terms of the estimated due date that was made up by the physician at the start of the process. They were making a value estimation decision based upon history and chemical testing and that type of thing. We're doing it using a model, but they're different. So Target, if you read the original article, it talks about their accuracy rate. There's an 87% chance this particular woman was going to be pregnant. So they assigned a probability to it. With the US election, I'm not sure how we'd evaluate the model performance. And there's a lot of distrust to the evaluation in many, many different quarters. The final stage is deployment, actually implementing it. So with Target, it may be sending out advertising and who's going to do that and how. What's deployment like with the election? How do we do it again in the future? Like elections, they're done every 4 years. So how do you maintain that model? Are there unintended consequences to the process you followed? With Target, it was scaring their customers by appearing to know too much. Um, they um, they from the original article, these are some of the quotes that they had of um, once they knew this was a likely customer, then they, because of other data mining applications, they knew how to use it in terms of emailing a coupon, or if the ad comes on Friday, is that more effective than sending an ad out on a Monday? If it's put on a receipt or something, how is it used? That different ways in terms that you're going to implement that type of thing. Now remember, with Target, this is someone that comes into the store. So as I said, they can target them with ads while they're in the store, is leaving the store on their uh, cashier receipt. Uh, Tricky. Um, that they had um, lots of success. That, but during deployment, that's when they discovered a bunch of ethical or privacy issues, and that mainly just sort of affected deployment, but it may make them rethink in terms of how this is used. Um, uh, yeah, they're always trying to sell you on their MasterCard. Their MasterCard, they're going to capture more data from you. They're going to get, and not, this is sneaky. So I'm not sure how much they're able to get out of the data, out of the MasterCard, and transfer it to Walmart because it's a MasterCard, so it's going through a credit agency. But it's being run by a Walmart essentially is operating its own bank that's part of the MasterCard network. And so it's providing credit services. So they're a lending agency now. But they're collecting data on your purchase transactions. And Walmart is collecting information about if you're using that when you're shopping online at Amazon. Walmart's finding out about your shopping behavior online at Amazon or at other retailers, other businesses. So it's a sneaky way of capturing data about your shopping at competitors. I don't know if there are any restrictions to, at least in aggregated form, using that data and feeding it back to Walmart. It's scary though. Think about it. um, with um, the US election, it's been a nightmare. Um, it's supposed to end on the 20th when the final inauguration takes place, but it's going to continue beyond that. Most Americans don't understand the whole electoral college system that they have in the U.S. and the whole process for selecting it. It's in some countries it's just whoever gets the most votes, nice and simple. The U.S. isn't. We already know, like Hillary Clinton got more votes than Trump did in 2016, but she didn't become president because that's not how their model works. Uh, there's, as we've seen uh, with the riot at the Capitol building, they don't accept the output, or some groups don't. Um, that there are a lot of, and some of the challenges through the process. I'm not sure about talking about the data, but there are a lot of unintended consequences potentially with the way the process unfolded and the way you mentioned, someone mentioned Ted Cruz about the actions of Ted Cruz and Senator Hawley in challenging the election, which is part of the process, may well have unintended consequences for them and for the U.S. as a whole. The model that was used there and the relationship, what are the consequences in terms of the U.S. relations with Canada, with Germany, with France, with Europe, with Russia? That it's more than just here is the single output. There are all kinds of other ramifications to actions, decisions we make. And you've got to think that in deployment. Uh, the US, if they used a simpler model, like winner take all, um, that it might make deployment a lot easier. Yeah. So you have to think about that. What would be a better model to use in making that selection? So it's a tricky sort of thing. But data mining is a process. It's not one tool, it's not one formula. I've got a start point and end point sorter. It's frequently messy. Um, our methods can be very messy. Our data is always messy. Um, and there are some guidelines, some suggested best practices of going through the steps. But these are only recommendations. Best practice is not necessarily what you should do because it's best in some context, and that may not be your context. So be careful about that sort of thing. Where am I at the moment? Do. Okay, so um, in terms of we're going to get into data understanding and what it looks like. That blog about Hillary, if you haven't read it, the person that wrote this blog a number of years back, she is someone that works in the area of data analysis, and she has a blog about data analysis. And her first name is Hillary. She hates the name, and that um, if you're familiar with Hillary Clinton, and maybe from the 2016 election you heard of her, but really she came to prominence long before that because of her husband, Bill Clinton, who had been the president. Bill Clinton, controversial figure, that some of his behavior was shameful in different sorts of ways. But he is very, very charming. People loved him. That very, very popular because of just the way he connected with individuals. His wife, Hillary, super intelligent, very capable woman, but with appalling interpersonal skills. Nobody liked her. Nobody got along with her. And um, they did not enjoy her as the first lady. She was too uh, uh, Americans like their vice president, or sorry, the spouse of the president, which has always been a woman so far, to be some supportive person in the background that helps out on worthy causes, but really is not a political person. Hillary Clinton was a highly political person and very involved. And as I said, was very unpopular as an individual. When she rose to prominence, initially, before people got to know her, the Hillary became a hugely popular name for babies. And you'll see baby names go in cycles. And this one spiked. But just a few years later, it crashed as people got, and nobody wanted to call their daughter Hillary anymore. And by 20, I think the article was written before the 2016 election, where the 2016 election was more who do you hate more? Do you hate Donald Trump more than Hillary Clinton, or Hillary Clinton more than you hate Donald Trump? It had nothing to do with policy. It was very much about personalities, and among two people that large portions of the US population really disliked. Uh, so, how do you prove that Hillary was the most poisoned name in US history? Not just one that was popular, then unpopular, but the change was greater um, than any other baby name in US history. That goes back a long way. What data would you look at? How would you analyze that? And so the blog shows the way she went through it once and then did it a second time in terms of reanalyzing things to, and it tells a fairly good story. And let me see if I can't weave that into a class if it isn't the next one. But it's a good story, and stories are important. Now I'm running over time. Um, and as I said, we'll get into that. I think that's my last slide. Is it? Must be. So let's end that. And I just want to show you one thing. Let me go here, back here. Now I'm not showing you my desktop, but a website I like going to just because I love things to do with data is called 538. And you're not seeing me or the chat anymore. 538, that's the number of electoral college votes there are. But they do a look at a lot of things to do with politics and sports. But I think it's under science. I'll find their COVID stuff. Come on, where are we here? But they do some great stuff in terms of data analysis. And here they do talk a lot about COVID data. And I just want to I don't want their polling, I want their predictions. Should be here. There it is. So they've done a lot of stuff about modeling and predictions. Now the modeling out of Ontario should be coming up very soon. And so there are a huge number of different models. This is US modeling, and it can be done at the state level or at the national level. And what you're seeing here, here's a simple picture that tells a story. This is the number of COVID deaths in the US from April, when there was pretty much nothing, to coming up to today. That's up here, or this is actually maybe 2 or 3 days ago because of reporting. And now the question is, where is it going from here? Let's have some forecasts. I'm out of time. But there are all kinds of different models. They're taking the same data, but you see this stuff here at the end. Hopefully you're seeing my desktop. These are different projection models. The red line is where they think it's traveling, and there's a gray scatter around that as to maybe a bit higher, a bit lower. And these are all different ones that have different, this one accounts for state reopenings, assumes that interventions will be reenacted if cases go up. And they've been making a lot of changes to the model. Here's one from Georgia Tech. It assumes the effects of interventions are reflected in this and will continue, but they make different assumptions about it. That this one is focusing about factors that affect transmission and how they change. John Hopkins, which is the best one to go to for the actual data, it incorporates information about stay-at-home orders or the effectiveness of social distancing measures and that type of thing. But there's so many different models, they make different predictions. And if I'm looking at January 30th, this one here says there are going to be 453,000 deaths, maybe as many as 469,000 by then, whereas the most optimistic is Columbia University at only 374,000 deaths. That I think they're oops, no, I want by the 30th, 398,000 deaths. I doubt that. I think they're going to be well over 400,000 by the end of the month at current rates, but different assumptions make different predictions. These are all value estimation models. So that sort of question, what does a value estimation model look like? There's one where there's some formula in behind that created it. Did you see my screen? No? Don't know. Anyway, I've got to go. I know you've got other things to do, so we're going to end the class now. And I'll speak to you on Wednesday. Oops. Oh, don't want to do that. What went wrong here? End class. You guys take care. Sorry I talked too fast.